Here are solutions to homework set number 9 for ECE 476. Now this homework set, the goal is to design a little embedded system with the Raspberry Pi Pico that will measure how high you can jump. So the way it works is when you hit button 14, it starts a short tree. When the light turns green, I jump. Once I finish my jump, it will display my acceleration, x, y, z. The line in the middle is 0 g's, top is plus 2 g's, bottom is minus 2 g's. Hit button 15. That's my acceleration. The time that I'm below 0.5 g's is considered your air time. So here my air time is 190 milliseconds for a jump of 4.4 centimeters. Again, not real impressive, but hey, I'm getting old. So that's kind of the goal of this homework set. So let's see how that's done. First, I want to read the GY521 accelerometer. So there's some sample code on Bison Academy for doing that. Basically, it sets up the accelerometer with an I2C interface. Then the main loop looks like this. I'm just going to read over and over again the acceleration in the x, y, and z direction, store that in a data file, and repeat every 10 milliseconds. Timing's a little bit off because I'm using time.sleep rather than interrupts. Interrupts would be a bit better. Once I collect the data, I'll show it on the screen. So this is kind of what it looks like. Next step. Once I can display the data, I'll calculate the acceleration. So the net acceleration is the square root of acceleration in the x, y, and z direction. That's what this does. To measure the time in the air, I will say if this is your leap, here's your acceleration. I picked 0.5 g as my threshold. Record this time, the time that I drop below 0.5 g's. Record this time, the time I go back above 0.5 g's. And the time difference is dt. Now if there's little glitches in the data, I will take the longest time that I measure in that data set. Once I know the time, I know the distance. Distance is 1/2 at squared, but again this is from 1/2 at squared is from the apogee to ground. This is the total time. So it's time divided by 2 squared. So this is 1/2 times 1/2 squared gives you 1/8. That's where the 8 comes from. And there's 9.8 meters per second, or in centimeters, 980 centimeters per second squared. That's my distance. Finally, I want to display the top 3 scores. So here I have a bubble sort. I'm going to have an array of 4 elements, the top 3 scores, and my current reading. I'm then going to do a bubble sort, that's what this is, a bubble sort, to take those 4 entries and sort them from largest to smallest. Wait for you to hit button 15, and then when you do, it'll display that second graph along with the text showing the top 3 scores. The net result is when you jump, you get a screen like this. So here's the current jump was 270 milliseconds. The distance was 8.9 centimeters. And my top 3 scores were 11, 11, 8.9. And here's what that jump looked like. And here's the start, here's the end, here's a couple stray glitches. That's the distance that I measured. Again, not real impressive, but, I'm getting old. So anyway, that's what I got. That's problem number 1. Can I measure my vertical leap? Problem number 2 says, now let's add a NeoPixel to it. So what that's going to do is, instead of starting right away with a beep and recording your data, I'm going to have a countdown timer. So that's what this does. When I hit button 14, it kicks out. I start with no lights on and start filling them in one at a time. So that's kind of what this looks like. Starting out, the lights turn on one at a time. The button right here, that LED is kind of stray. I'm using the NeoPixel routine, which is slightly wrong in timing, so this light doesn't quite work right. After all the lights turn on, it displays that leap. In this case it was 0. Hit button 14, and it will display the next acceleration. So let's do that again, only now I'm going to move the accelerometer a little bit. So here's the starter tree. When all the lights turn green and I hear a beep, it's time to start recording. So I'll move the accelerometer around. There's the net acceleration. Hit button 15. Here's the total acceleration. When it dropped below 0.5 g, that's when it was in the air. That was on for 10 milliseconds for a corresponding height of 0.01 centimeter. Well, I didn't have to actually jump. The last part is a demo, so let's do that one more time. Okay, so here you can see the lights. Up a little bit. Here you can see the lights. When I hit button 14, the lights start turning on. That's my countdown timer. When they all turn green and I hear a beep, I jump. There's a jump. The result is shown here. This is my net acceleration. The red line is 0 Gs, or actually that's 1 G. The green line is 0.5 Gs. The bottom of the screen is 0 Gs. The time that I'm below 0.5 Gs was recorded as 300 milliseconds. The corresponding height is 11.025 centimeters. And that is my record. That's the highest jump I had in the last 3 tries. That is homework set number 9 for ECE 476.